Hi everyone, how are we doing today? Hopefully it's been a great day. We are going to start 5, 6 inequalities in 2 triangles. You're going to be able to apply the Hinge theorem, which we're going to learn, or its converse, which we're also going to learn, to make comparisons in 2 triangles. And then in class we're going to head back to proofs and we're going to prove triangle relationships using the Hinge theorem or its converse. So you're going to need your packet for the Hinge theorem and the converse of the Hinge theorem. And go ahead and write this example down. Pause the video. Okay, so what this is saying is that if you have 2 congruent sides, so we have AB is congruent to FG right here, and we have AC is congruent to FH. So we have 2 congruent sides, and it's saying that if this angle A is bigger than angle F, then this side BC is going to be bigger than the opposite side GH. So that is what the Hinge theorem is telling us. If we have 2 congruent sides and this angle in between those 2 congruent sides is bigger than the other angle, then we can assume that this side is bigger than the other side, the opposite side of the other triangle. Okay? Now the converse means that we flip that around. So let's say that we have, again, 2 congruent sides here. PR is congruent to JL. And we have RQ congruent to LK. And we're also given that the opposite side of the angle is bigger, so PQ is bigger than JK. Then guess what? We can say that the measurement of angle R is going to be bigger than the measurement of angle L. So that's what the converse is saying. Okay, now that you know what this Hinge theorem is saying, go tell somebody right now. Go tell somebody what it is. I'll time you. Pause the video. Ready, set, go. Did you tell somebody? I hope you told somebody, because that's the best way to learn. And you never know when you're going to need to use the Hinge theorem. All right, so let's use the Hinge theorem right now. So here we have a triangle, 2 triangles rather, and we want to compare using inequality signs WX and XY. So WX here is right here, and XY is here. So we know we have congruent sides. WZ is congruent to YZ, and we also know XZ is congruent to itself. Now using the Hinge theorem, it says that if that middle angle is bigger, like so, than the other middle angle between those 2 congruent sides, then we can say that XY is going to be greater than WX. Okay, because of the Hinge theorem. Let's try another one. Why don't you pause the video and see what you can come up with. So we know that FC is congruent to CF, and we also know we have BF is congruent to CD. So let's look at the angles opposite of these sides. So 3.6 is definitely better than 3. So what's opposite of 3.6? Angle F right here, angle BFC. And what's opposite of angle 3, or side 3, is going to be FCD. So which one's going to be bigger? 3.6 is bigger than 3, so therefore we're going to say angle FCD is going to be less than angle, and I probably should put my angle signs in here, holy smokes, BFC, because 3 is less than 3.6. So this is the converse of the Hinge theorem. Alrighty? So let's use the Hinge theorem to solve for x. And we're going to find a range for x. So x has to be in between two numbers. So let's look at this triangle. I'll let you pause the video, write this down, and see if you come up with any solution. All right, so we are looking across the way here because we have two congruent sides. So 65 is across from 9, and 6x plus 15 is across from 11. So we know that this angle has to be greater than 6x plus 15 has to be greater than 65 because 11 is greater than 9. So when we solve that, we're going to get 6x is greater than 50. Divide by 6 on both sides. And we're going to get x is greater than 8 1/3. So we know x is going to be greater than 8 1/3. Now, is there anything that this angle has to be less than? Yes, it has to be less than 180 because that's what they all add up to, all the side measurements. So we know it cannot be greater than 180. So when we do that, we're going to have 6x is less than 165. Divide by 6 on both sides. And we're going to get x is less than 27.6. So the range then that you could write this as is 8 1/3 is less than x, which is also less than 27.6. Now, if you left it as this and maybe wrote the word and in between, I'll accept that. But when you get into Algebra 2, you're going to be writing your inequality statements like so. So it's a good way to practice this. And if you don't understand how I did that, go ahead and pause the video, rewind, and see what I did there. Okay, now what about finding the missing side? Pause the video, write this down, and brainstorm what methods you would use to find the range for x. So we're using 5x plus 2, excuse me, and we know 68 is greater than 55. So if 68 is greater than 55, or 55 is less than 68, let's go ahead and write that 55 is less than 68. And across the way from 55 is 5x plus 2. And across the way from 68 is 47. So let's go ahead and solve this. And I'm going to back up a second here. Why can we use the Hinge theorem? Well, we know this side is congruent to this side, and 50 is congruent to 50. Okay? I just want to make sure that we are using the Hinge theorem here. Actually, yes, we are using the Hinge theorem. Alrighty, so we're going to subtract. So we have 5x is less than 45. So x is going to be less than 9. So we're looking for a range. We know the side length, and I know this is silly. I found this very silly. But we know that the side length has to be greater than 0. We cannot have negative side length. And so when we solve that, we're going to have 5x is greater than a negative 2 and divide by 5. And so x has to be greater than a negative 0.4. If you want to leave it as a fraction, feel free to do so. So when we write this, we know that x is greater than a negative 0.4, and it's also less than 9, which is our answer. Again, rewatch the video as many times as you need to. I want to make sure we have a good basis for this because tomorrow we are going to be using the Hinge theorem in proofs. Alrighty, let me know if you have any questions. You can write it on the blog there, or you can have them for class tomorrow. Bye guys, have a wonderful day.